Yeah, hi and welcome to Object-Oriented Programming 1. It's week 2, lecture 2, and today we will finally talk about objects, as the name suggests. So we will have a look at classes. What is a class? Why do we use classes in object-oriented programming? And then why we use objects, how we can use objects, and also many other small features of C++.
And why are we here today and not Michi and Julia?
Because it's actually a double lecture today. So we will have an extensive look at classes today, but Michi and Julia will be here in, I think it's 3 weeks.
I think in 2 weeks.
2 or 3 weeks.
I don't know. Yeah.
Then it's going to be a double practicals session. Yeah, so we are in week 2. We have the second lecture today. And before we start with the lecture, a few organizational matters, which is about the homework 1.
Yes, so we are releasing already the first homework today, and it will be available in Teach Center today after the lecture at about 7 p.m. And you can find it in the Teach Center. I think it is for 2 weeks, so you have 2 weeks time. And the homework is about all we are talking today. So object-oriented programming classes and all what belongs to classes. So what you have to do is write your own first classes. And we are using a brand new tool into the Teach Center where you actually can write code in the Teach Center. And we want to test it with this homework. Yeah, so you will find there, I think, 3 coding tasks with different test cases. You can write their code in the Teach Center, and then you can also see if you pass the test cases. It's worth only 2 points of 100, so don't worry if it's not that much, but I think it's a good start to get familiar with classes and object-oriented programming. You have an arbitrary number of attempts, so you can redo it as often as you want. We only count the best one. So please, if you feel you can do better, just do it once more. It's more about you learning how to write classes than doing it perfectly in the first attempt. All right, if you have any questions about the homework, just ask on Discord. We are happy to support there.
And also the submission is directly in the Teach Center, so you don't have to push anything into a Git repository. It's directly in the Teach Center. Great. With that, we can now start with the recap. And for that, we have prepared a few quizzes on Slido. So I hope you're familiar with this tool. Just scan the QR code or visit slido.com and enter the code here. And yeah, we want to find out what is the output of this code snippet here. So last week in the very first lecture, we had a look at the basic C++ syntax, arrays, range-based loops, maybe also references, might be a good hint for this quiz. So try to guess the output based on the given options. Now we also have auto here. I've missed it totally. Another cool feature we have learned about last week.
So this is what you should have seen from last time, hopefully, or remember from last time.
Okay, let's wait a few more seconds, I would suggest, and then let's have a look. Okay. Let's win until we have 75. Perfect. So, what is the output of this snippet?
Oh, yeah.
It's
You tricked a few of them at least. Great.
no, it's changing. Yeah, of course.
No, they are all correct. Yeah.
Yeah, it's actually 1, 2, 3. Why is this the case? So if we take a look again at this code snippet here, it's because we have this range-based for loop here, which iterates through the array here. But we do not modify the actual values of the array, but we modify the values that were copied into this variable here.
So that's a bit tricky with range-based for loops. They don't use references implicitly, so you have to write it on your own if you want to modify the actual value inside.
Okay, then let's continue with the next question. To be honest, this one is really tricky.
Oh yeah, I also struggled with that one.
Yeah. So if you have done introduction in structured programming, we have talked about arrays that were created in a function and then returned. So maybe this is a hint for this question here. So maybe think about where are local variables stored, how long do they exist, how long does the associated memory area exist. Maybe this could help you for this example here. So take a close look what is returned. So if we even have an even number here, if an even number is returned, or if we return the not found value.
Okay, so
It's
last seconds for you to decide.
and yeah, let's
see.
have a look.
Yeah,
Yeah,
that's tricky.
was really tricky. If you try this on your own laptop, most of the time you will get -1 as output, but actually you will also get a compiler warning, and the behavior is actually undefined because you return a variable that is on the stack of this function here, of the first even number function,
But why do I return a local variable?
because we return a reference.
Okay, and which variable do we actually return?
We return this variable here.
Okay, yeah, because there is no even number in the vector. Okay, so we are returning this not found variable.
And then we access the value of the variable, or actually the whole variable here, and it doesn't exist anymore actually. So we should
Because it is a reference to the variable that is already deleted.
Exactly, yeah. So it doesn't exist. The value still can exist. So if you try it, you probably will get the value -1.
But we cannot guarantee that it still exists.
We cannot guarantee it, yeah.
So it would work if we remove the reference from the integer here, right?
Yeah,
Okay.
that would be perfectly fine. Then it would always return -1 and print -1.
So same principle why we should not return a local array from a function. Same here, do not return references to a local variable.
Okay, then the next one. So here you should fill in the blank. So you have multiple options of function calls. And last week we talked about function overloading. This means we can have multiple functions with the same name, but with different parameters. So either different parameter data types, different number of parameters, or different order of parameters. And in this case, we want to append 1 to our message. And we are now looking for the function call that will result in an append of 1. Okay, let's wait 10 more seconds. Okay, and let's have a look at the correct function call. Yeah. Again, a bit tricky, but this, okay, change now. This data type here is not the same as this one here. So there is no function that can be exactly matched with the reference, the address of, thank you, of the message variable. So you won't find any function. That's why this function call will result in OOP1.
So maybe let's go back.
Yep.
And let's check it once more. So we call this one here. Mm-hmm. But as you can see, this number is not used here. We're just adding hard-coded value 1. But we want to find a function call that calls this function here. And this only works if I have a text. Okay, they all have a text. And an integer. No character, no double. The second parameter must be an integer, and this is the integer here.
And also no pointer,
yeah,
like in this case.
Last one, I think, for the recap. Yeah,
the last one. So now you have multiple options you can select. What do you think? How could this code be improved? So there are several parts in the code that can be improved, and what we have learned last week. So what do you think could be improved here in this code snippet? Yes.
Okay.
Okay, let's
see if I can.
Configuration on our side.
Yeah. I don't know if it works real time. Does it work now? Yeah, great.
Thank you. Let's wait again 10 more seconds, and then let's see how we can improve the code.
Okay.
Perfect. So most of you got all of them Correct. That's really great. So if we now continue, so yes. Sorry, I didn't get the question. The range based,
yeah. That's a good question.
Good question. Just to repeat it, why is, okay, I can't view it here. Why is the vec.add an improvement in this case? It would be an improvement if we wouldn't use range-based for loops.
Yeah,
So
you're correct.
You're absolutely right. If we use range-based for loops, there is no necessity to use the vec.add function call. Yes?
Why are references an improvement?
As we have heard last week, in this case, it won't matter. So we only have 3 elements in the array, but let's assume we have 1,000, 1 million, a huge amount of elements in the array, and we wouldn't pass it by reference. So we would have to copy all of the elements to the function and then use the copied values there. So it's very time consuming if we have to copy a vast amount of elements. So it's basically the efficiency. And also if we want to modify the value, in this case we don't modify it, but if we would like to modify it, then we should also use reference. Yes?
So when you copy a vector, do you also copy all of the elements of the vector?
So the question is, when we copy a vector, can we also, what would... So it really, okay, the question is, does it really copy each and every element in the vector, right? Okay, yes, it does. So as soon as you call a function and you hand over a vector, the complete vector, including all the elements, get copied. So there is a second vector in your program with the exact same values inside. And most of the time you don't want this because you want to work with the original vector and you don't want to get a copy of it. Mostly if you say you want to modify the original vector, or you just don't want it because it's very time consuming. So in most cases, you want to work with the reference and don't want to have a copy of it.
So this is also the reason why we use the reference here in this case. So that's one improvement. Then we also have a range-based for loop here. If we wouldn't have this range-based for loop, then we should definitely use the vec.add function. So to receive an exception if we, for instance, access an element that is not in the or out of bounds of the vector. Yeah, so that's basically the improvements for this code snippet here.
Yes.
Is the reference in the for each loop necessary?
No, not
In
really.
this case,
Not really in this case because we don't modify it. You can do it, but it's not necessary. We just want to give you examples where we can use references.
great. Any other questions to this code snippet here? Yes?
So maybe just to continue with to the last question, if I would not use the reference with the for loop here, would it be any difference in the timing, the time consumption or the memory?
Yes, a bit. So the question is, if I don't use, I think, this reference here, is there any difference in time consumption? Yes, because every element gets copied, but the iteration and the output, the printing takes so long that this is not very, or this is not so much, how can you say it? Sorry? Okay. Yeah, I think you can neglect this time of the copy because the printing is so time consuming, but it is slightly different. Yeah.
Okay, then before we dive into classes and objects, let's have a brief look at enums in C++. So I see most of you are already familiar with enums, probably from Introduction to Structured Programming. And we've learned last week that we don't need the type def anymore, which is quite cool, I would say. But we don't only have enums, but we also have enum classes in C++. And it's basically the same, except that you can here have, for instance, two enums with the same names. But you can, as we've seen last week, with namespaces, then use the name of the enum class together with the scope resolution operator here, so the two colons here. And so we can use two enums with same values, but with different enum class names.
So is this already a class now? Is this object-oriented programming we're talking about today?
Not really.
Not really,
Not
yeah.
really.
It's just maybe not the best naming for this enum class. It's just an enum where we can use namespaces.
Yeah, I would also say it's rather namespace than really a class. Okay, then I would say let's really start with classes and objects. Yeah, classes and objects. In general, when we talk about classes in object-oriented programming, we always think about some blueprints we have, which has some properties and some behavior. And with these blueprints, we can then create objects. So,
what is an object?
An object, we'll see that soon.
Okay.
But as a teaser, an object is one instance of a class. So we create an object of a class which then has, for example, different properties. So bats can have a type, most likely, and also an age. And now, when we create objects, all of these objects can have different types and different ages. But let's first compare traditional C structs with C++ structs. They are actually quite similar, as we've heard last week, but we don't have to use the type def anymore. We don't have to write it anymore. We can simply write struct, in this case pet, and then we have the members. So the only difference of the members here is that we can use the std string instead of a character array. And then we can simply create an object with, in this case, a cat and the age 4, and then print it. So it's quite similar. There's not really a big difference. This is called plain old data class. So we have a new data type, which is simply a composition of existing data types. So we have members of different data types and then create a new data type based on this composition. Different data types is also important because that's one big difference to an array. When you've used arrays and worked with arrays, you only had the chance to have one data type, to have elements of one data type in the array, but with a plain old data class, with a struct, you can have multiple data types. The elements in such a plain old data class are called members, or sometimes also fields, but we will stick to the term members from now on. And C structs are basically plain old data classes. But when we now work with C++, we don't want to have any structs anymore. We can have structs, of course, but we want to have classes. They have a lot of advantages, and we will get to them soon. So instead of struct pet, we can now write class pet. So the syntax is quite similar. Instead of struct here, we can write the keyword class. This indicates that this is going to be a class. The members stay basically the same. So it's again a string with the type and integer value for the age of the pet. But it's a bit different now how we can create such a class or an object actually of a class. We can again set the value of the members here and print the value. So this is quite similar.
It's actually very similar, but when we execute it,
Then
we
we
get
will
an
see
error.
private member of pet. That's strange. What is private?
So that's a difference to structs, obviously, because we can write it with structs like this, but not with classes anymore.
So we have to add something additional, which is an access specifier. So if we want to access a member of a class outside of the class, we have to define the access specifier public, or we can also see then next week, I guess, protected. But for the moment, if you want to access members outside of a class, you have to put them under the public access specifier. And with that, you can then create an object of pet, access the members, print the members, modify the members, whatever you want.
So what classes basically are, is this, it's basically the same as structs, but we can put a lot more inside. And we have, so like specific regions inside the class. We have a public region and we also have a private region. So let's talk about access specifier and about these regions inside of classes. We have a public region, and public means that the members are accessible outside of the class. So for example, the name and the age, whatever you put inside this region, which is public, can be accessed outside of the class. For example, inside the main function. Then you have a private region. Private means nobody outside of the class can access this. So now, why would I use that? Of course, it sounds a bit odd. Sometimes you want to protect your class, and we will have a look at this shortly. And also the third type of region we have is protected, but we will talk about that next week. Yes?
Could we also make the whole class public, so we just write public class pets?
You cannot write it directly like this, but theoretically you just put everything in the public region and that would work. But that's not good practice. Yes?
That's a very good question. So if I got it right, if we don't specify any access specifier, by default, everything is private in a class.
Yeah, that's why this one fails, because there is no access specifier and everything is private.
That's also one huge difference to structs, where you can access the members of a struct outside of the struct. But you cannot do it in a class if you don't put it in the public region of the class.
So what's prohibited here is the cat, which is a local variable here, and I want to access the member type, which is here in the region of private, and this does not work. So I cannot access this and the age too. This does not work until I move it into the public region, and then I can access it from outside. Outside means every other function, whatever, outside of this current class. So this private thing is a very, very central object-oriented concept. Why would I use that? So again, we have our pet with our type and the age. And let's say we gave it an age of 60. So my cat is 60 years old.
Really?
We have done our research. Cats cannot live 60 years. So the oldest one is about 38 years old, yeah? And so that would not be possible. So we have to somehow prohibit maybe myself or also the user or my programming colleagues to set an age of a cat like this, because it just doesn't make sense. Also, maybe the age of -50 would not make sense. So what we can do now is we use so-called public interfaces or specific methods to modify and access the members. So this is basically what you should do. All the member variables should be set to private because they should not be accessed and modified directly. What you then should implement is a so-called setter method. And this is a specific method inside the class, in the public region, so it can be called from outside. And this one controls how your member variable is set. So I can then call into the main function, I create my cat, and I call cat.setAge, and I can set here the age, for example, 5, it would work. But if I set it to 25, 50, whatever, I have a control variable here, and I can say, okay, only if the age is smaller than 20, it makes sense. Then I will set it. Otherwise, I can handle it. I can print out this just makes no sense or whatever, but I have more control over how my object, my pet in this case, is modified. The other way around, we also have so-called getters. I cannot access the age directly because it's private, so I need to write another function, a getter function, to get the value of my age. And this getter function is then public again. Yes?
One quick question. The thing is that it's standard private in classes, the variables. Is that for group programming or something? Because it doesn't make much sense for me why you should protect it extra if you know it shouldn't be accessed in certain ways. If that makes sense. I don't know.
So I don't get the point you're making here, to be honest. So you don't get why we should protect ourselves or my colleagues from making mistakes, or what is your question?
Or why is it by default private, you mean?
Yeah. Why shouldn't it be accessed from outside?
Okay, so why should we use private at all? Yeah. Let's phrase it like this. As I said, one thing is, for example, that you have more control about setting your variables. In this case, of course, this is programming, yeah? So I'm doing this. But let's assume this is a user input, and the user defines the age of my cat. So I cannot control what the user does, but I can create a method that say it only should be set if this is a valid age. And then I have more control about the user input, for example. It also is a bit the same if I have a good idea of a class and we are working in a team together. I maybe also want to protect myself of making mistakes from him or fixing mistakes from him. So I can define, do this only in this specific way I define here. You are not allowed to modify my member variable. I allow you only to use this specific method, and I have more control how he is programming.
So it's basically protection to not break the class.
Yes, it's a protection mechanism. It does not really change the program. It's a bit more work to do, yes, a bit overhead in work, but if you have huge programs, it's really a benefit. Yes. Sorry? A for loop. Yeah. Okay, yeah. It would be the same if I have like, if this is my user input, I can only write it there for of course, but I have to write it every time when there's a user input. And in this case, I can only like do it in the class and only write it once, for example. I know that there's at this point, at your current knowledge, a lot of question marks why we should use private. But when we do the assignment 2, which you will do in a group work of 3 people, you will see it has benefits from doing this encapsulation, writing getter, writing setter, and so on. So from now on, please just trust me that this might be interesting in future. Okay, so we have our getter and our setters. And there's a new quiz.
There's another quiz. And yeah, it's actually about setters and getters. Again, I have to admit it's a bit tricky. Yeah, let's see. So we have the class pet here with an age and a setter method and a getter method, which sets the age and returns the age. And then in the main function, we create an object of this class, set the age, and then print the age.
Does it make sense to have a goat as pet?
I would say so.
Maybe not in an apartment, but
yeah, maybe it's not the best choice for a pet, but okay, let's wait a few more seconds. So I would suggest to have a close look at the class.
will you fool us again? Is there a trap inside? Let's see.
Let's see. 5 more seconds, and then
Yes.
whoa, great. That's awesome. Many of you got it right. Does anyone have an idea why there isn't compiler warning?
Yes. It's not public.
great.
Everything, also the getters are private, so we cannot access them from outside. Yes.
Perfect. That's great. So at least the first step into understanding access
Yeah.
specifiers. It's really great. Okay, let's continue with the pets.
There was one question,
sorry, yeah.
sorry.
No.
Oh,
Yeah,
I waited for that question.
Yeah.
What does this const mean? We will actually talk about this in a few minutes. So
We would ask you
patient.
to just wait
yeah.
15 minutes and then we will dive into const. Any other questions to this code snippet here? Great, then let's continue with our pets. So we have properties. We have the type, we have the age, but the pets are alive. They do something.
Yeah.
This means they have some kind of behavior. Pets should eat, they should sleep, they will move, they will also most likely make some noise. And that's now the two parts of a class that we're interested in. So we have properties, which is just some members, and then we have behavior, which is then methods. Methods are just functions which belong to a class. So we have functions within the class here. We have a function make noise, we have move, and this then belongs to a class or actually to an object that was created. with the class. So if we create here an object cat, this cat can make some noise. But we can also have a dog, for example, and most likely a dog will make another noise than a cat.
Hopefully.
And this also applies to any other pets we want to create or create an object of. So this means that each method is, belongs to an object that was created and therefore can have different behavior based on the object that we have created. So think of any pet, create an object of it, and hopefully most of them will make different noises. So this is called methods. They belong to a class or actually then to an object.
So this is a very, very essential concept.
Yeah.
And we will build on this for like next all of the lessons. Is this clear? So we have a class, we have our members, like the age, the type, the name, whatever, and we then can define functions inside classes that belong to these objects, and we call this methods. There was one question. Can we have a method outside of the class? When you have a method outside of class, it's just a function.
Yeah. So it doesn't belong to an object.
It's a function then. When it's basically it's the same, the function, but a method is a function inside a class. Or do you mean can we write methods which belong to a class outside of the class? Yes, if this is the question, yes, we can do, and we will show that.
Perfect. Any other questions to methods so far? Because basically, methods, yeah, there was one question.
What side of the class for a class is when the variables are public, right? Or is it something special?
Outside of the class is only possible if they are public, yes.
Perfect. So methods are basically functions, but they are part of the class. They belong to one class. So to sum it up again, we have member variables. These member variables should always be private. So we put it in the private region of the class. And then we have methods. Methods define the behavior of a class or actually an object. And there we can have, for instance, getters and setters, which should be public, which we can then use to modify some members or to get some member variables. And of course, we can have additional methods. Like we had it for the pets, we have some make noise method, move method, maybe eat method, whatever. Are there any questions to access specifiers, private, public, properties, and
I actually have a
methods?
question.
Yes.
You write here methods can be public. Can they also be private?
Yes, of course. They can be private. I'm not sure if you will work with private methods in the first assignment. I'm not sure.
I'm not sure if they're in the first assignment,
Yeah,
but basically, every time you do not want a method called from outside, you can make it private. For example, you only want to use it inside your class for some calculations or whatever.
So, yes?
Can I only use this private, public, and protected once, and I need to structure my code like that, or?
Very, very good
Yeah.
question. Can I use this private, public, and protected only once? No, you can write it as often as you want. So you can have a public section, a private section, a public section, and so on. There is no limit. Any other questions?
If you write some functions and then do public, the thing before that's not written is still private, right?
So you mean if you have members or functions, also methods that are not in any access specifier region, they are
They are
by
private.
default private.
Yeah. If it's not defined, it's always private.
Yeah.
Yes. But as soon as you define one, everything below is like this. Yeah. Okay, then move on to how we can create objects.
So now we introduce a new term which is called constructor. I'm not sure if you have heard it before, but a constructor is basically a function or a method which has the same name as the class, but it has no return type. So, and looking at it, it looks a bit strange. We just have the class name and then, yeah, the parenthesis here and some body of the constructor.
How does this constructor help me? What's the benefit of it?
Without a constructor, we couldn't create any objects at all from classes. So we have to have a constructor. Otherwise, we cannot create any objects of a class. And as soon as we create an object, in this case here we create a pet again, then this constructor is then called, which we have here, and we can put anything we want inside of the body of the constructor. We can, in this case here, initialize the age with 0 and then print something using stdc out.
So do I have to call this constructor?
This is done implicitly, in this case here. So we just write pet p. This is the data type, this is the object, and as soon as we declare this object here, this function here, so this method, or actually the constructor, is called, and the code inside of this method is then executed. So we don't have to explicitly call the constructor.
Cool. So in C, we maybe would call an initialization function that creates all my members and builds my object. I can do this with just one line and then writing a constructor.
Just one line, writing a constructor. We will see very soon that we don't even have to write explicitly the constructor if we have a default constructor, but we'll see that.
So we have different kind of constructors.
We have different kind of constructors. So we have learned about function overloading last week, and this also applies to constructors. So we cannot only have one constructor, but we can have 2, 3, or I won't spoil too much because there's a quiz then. We can have multiple constructors. So the most basic constructor is without any parameters, which is, this case, the constructor here. This is just a default constructor, no parameters, and yeah, you can do anything inside the body of the constructor, whatever you want. But we can have multiple constructors. They have to differentiate in the parameters, so the data type of the parameters, the number of parameters, or the order of parameters. So it's the same as for function overloading in general. And yeah, based on the constructor that is then called, you can have different behavior. How the pet in this case should be initialized, for example. And another cool feature that we can use here are initialization lists. So we put this colon after the parenthesis here, and then we can say, okay, the age that is passed as parameter to this constructor is set to the member variable age, and the same for weight. So we don't have to say age, so the member age is age, weight is weight, but we can say with this initialization list, just use age, so the parameter age for the member age and the parameter weight for the member weight. That's a really cool feature. We will see shortly why we should use initialization lists whenever possible.
I know this is just a code snippet, but wouldn't it be better in the default constructor to initialize every member of the class?
This is, yeah, so the question is, why don't we initialize all of the members in this code snippet here? It's just an artificial example, yeah.
Yeah,
But
yeah.
would definitely makes sense to initialize all the members here.
And you should always use the initialization list if possible. So the first one here could also use the initialization list instead of writing it into the function body. The second one too, like the third one is doing. If you don't know the values, for example, for age and weight, just set it to 0. Yes?
Yeah.
And age underline, and then you use the brackets and the age inside. Can you also use an equal sign there? Or do you need to use this?
So the initialization list is a bit different than writing code. You have to use this notation. So the first one is always the member, the age underline, and the second one is the argument you're handing over. Of course, you can use different names, but this is like very, very common to do it like this. And we also defined in our style guide, by the way, that all the member variables should have this underscore at the end, so we can differentiate between variables and members.
So now you get the reason why we use the underline. Sorry. Yeah. I'm not sure if I got the question. Yeah.
Okay, so do we have to initialize all the variables in the initialization list? No, you can do a few of them. You don't need to have an initialization list at all, most of the time. You can also write it like this, and everything is in the body, for example, but you should prefer the initialization list in most or maybe in all cases. Because this is just a runtime or performance improvement if you use the initialization list.
Is this the only difference between these?
In this case, yes. We will come later on to concepts where we need these initialization lists, but for this concept or for this example is the only difference.
Any other questions to initialization lists?
I know this can be a bit tricky in the beginning, but we also included it into the homework, so you can try it out there.
So why should we now use initialization lists? So David already mentioned it. On the one hand, it's definitely more efficient than initializing everything in the body of the constructor. It also works for constants and references. And with initialization lists, you avoid a reinitialization for fields with the default constructor. So whenever possible, please use the initialization lists. But now, do we even have to write our own constructor? Is it really necessary? Because when we now have this code snippet here, for instance, we create an object, again, cat. It's quite similar, or actually the same as we've seen previously, and there we didn't have a constructor, but this works. Why does this work? Any ideas why this works?
The compiler generates one for us.
Exactly. The compiler will generate a constructor for you, and we'll call that default constructor. So if there's no zero argument constructor in the class written, then the compiler adds a default constructor, and as soon as the programmer then explicitly defines a constructor, the compiler will do nothing more. So if you don't write a constructor at all, an empty constructor, so with no parameters, will be added by the compiler. This is then called the default constructor. But as soon as you write an explicit constructor, the compiler will not do anything more.
As soon as you write any constructor with any number of arguments, the default constructor
is gone. So when we now create such an object, and we as a programmer have written our own constructor with one parameter int age, And then we want to create an object without any parameter. So without passing anything to the constructor that we have declared here. Then the compiler will say, okay, wait, there is no such function, or in this case, no such constructor. I cannot compile this code. So we have to take care, as soon as we write an own constructor, for instance here with one parameter, we then have to think about what is the case when an object is created without any arguments passed to the constructor. So we have to add the default constructor manually. And how can we do that? We can simply add this line here. You will also see that in the first assignment. So you just say, okay, the default constructor without any parameters is equal to default. And then the default constructor is generated by the compiler. And then also this code here works. Are there any questions to the default constructor? Because in the beginning, it's definitely confusing. When do we have to add a constructor? When is the constructor added automatically by the compiler? So it's not as straightforward.
There was one question. Sorry? So if I write it like is equal to default, I think they will set it to 0. And the string will be just an empty string. I think there was one question.
Can you define values with the default constructor, or is it not possible?
No, it's just writing is equal to default. Otherwise, you have to program at your own. But programming on your own means just using brackets. It's not that much to do.
Why do we have to generate the default constructor manually?
The compiler removes the default constructor as soon as you define your own constructor. So if you want to use the default constructor or any or a constructor without arguments, you have to explicitly write it once again. You can do it like this, and writing it is equal to default, or you can just implement your constructor without any arguments on your own. But it's gone as soon as you implement one other constructor. Can we set constructor? Wow, that's a cool question. Yes, you can do, and there is actually maybe many or more possibilities, but there is one programming pattern where you actually want to have it, but we will discuss that later on. Yeah.
But it's possible.
Yeah. Actually, there is maybe we can make this short journey into advanced programming. There's something called a singleton. And there you only want to have one object of a class, and you can set the constructors to private to not create another object of it. Yes?
So, as I understood from the first question, the compiler defines the constructor will initialize all the variables of an object, right?
Yes.
And the second question was, can a constructor do something else apart from initializing values?
Can a constructor do like more than just initializing things?
For example, maybe having some like debug
Yeah.
to see if our objects are created correctly.
Very good question. Yes, it can do anything.
Yeah.
It's basically a function. You can do anything inside the body of the function, whatever you want. So yeah, it's not only initializing, you can do whatever you want.
So sometimes classes and objects are a bit more than, okay, a bet is you can do a lot of different things in a constructor, but if you have like a car class, a car has again, so much functionalities. When you create a card, it's not just one line, maybe it's thousands of lines. So the constructor can do all of this, of course, yeah.
Any other questions to the constructor? Okay, then we have prepared another quiz. And this time it's about statements that are true about constructors. So I hope you can now choose multiple answers. If this isn't the case, please let us know. Then we will try to change it in real time.
Yeah, it should work.
Perfect. So constructors do not have a return statement. You can create a maximum of 3 constructors per class. There is always a default constructor. The name of the constructor is always just the class name. And the initialization list only works for the constructor without parameters. So, which statements are true? Okay, let's wait 10 seconds and then we'll see the correct statements. So, yeah, awesome. Most of you got it right. So, a constructor does not have a return statement. Also, the name of the constructor is, just the class name. So, it's just a function with the name of the class. There is always a default constructor. Well, that's not the case, as we have seen in the previous slide. The initialization list works for both constructors without parameters and with parameters, and you can create any number of constructors per class you want, as long as there is a difference in the number, type, or order of parameters.
So
Great.
we talked about creating an object. Can we destroy an object?
Yeah, we can destroy an object, and this term is now called destructor. So when we create an object, it's constructing an object, so the constructor, and at the end, when an object should be destroyed, this is then called the destructor. It's, again, just a function, quite similar to the constructor, but we put a symbol before the name of the class, in this case, a tilde, and as soon as we define or declare the function tilde and name of the class without any return type, we have a destructor. And the destructor is then called as soon as the object is destroyed. We will see in a few minutes when an object is destroyed. And this is again a function that is then simply called like the constructor.
So I can write code inside the body of the destructor and do whatever I want there.
There are many use cases where you should do this. So in this case, okay, it's just a standard cout. But if you have, for instance, some memory allocated and you want to free resources at the end of the lifetime of an object, you will then most likely do that in the destructor of an object.
So I have a question, but I know we cannot answer it now.
Yeah.
When will the destructor be called?
There are different cases the destructor will be called. For instance, if the variable goes out of scope. So in this case here, we create the object and the constructor is called, and as soon as this local variable here goes out of scope, so when the return statement is executed, the cat object doesn't exist anymore, and then the destructor is called. This is just one case. We will see in a few minutes when the destructor is called in other cases.
And why would I like to destroy an object?
Because maybe there is some, yeah, we will see it in 1 hour, but there can be some resources that should be handled before we cannot access these resources anymore. And that's why we do that in the destructor, or can't do that in the destructor, but we'll see that in approximately 1 hour. And yeah, another cool feature, I think it was introduced in C++ 11, if I'm correct, is the brace initialization. So the brace initialization is just another method to initialize your objects or variables, whatever you want. You can initialize primitive data types, which is int or bool, character, double, float, but you can also initialize aggregate data types. For instance, objects that you have created using classes. And
so the important thing is here, there is no equal sign. You don't need it when you initialize it like this, because the first parameter, in this case the name, will be set to the first parameter, to the first member. The second one will be set to the second. So it is like a function call, but you are creating the object with it.
I think, or what I'm thinking is that you cannot use like keywords to specify the arguments.
No, you cannot use keywords like, for example, in Python. You cannot write name is equal to this, age is equal to this. This will not work. You have to manually look what's the first member and then write the appropriate name or
stick
value.
to the order.
Yeah.
Okay.
This also works for primitive data types.
Yeah.
So you can initialize an integer, for example, like this. And you can work with this. It's pretty much the same as you write, in this case, int age of cat is equal to 4. You can also do it like this. And this is also the usual way to initialize a vector, for example. We have also seen it before. So you can use this brace initialization for any data type, and it has some advantages. For example, it warns you in cases like this, and it will be an error.
So if you would write this as usual, so int value is equal to 7.9, it would be 7, but in some cases you don't want to have this behavior, and then, for instance, you can use brace initialization, which then throws an error when you want to do that. So that's just one advantage of brace initialization.
And it's basically, you can be very consistent over all initializations. So you can create integers like this. I already said about the vectors. You can create vectors like this and also strings with this. Both works. It's pretty much the same as using the equal sign, but this has a few advantages, as we have seen before, with the rounding of integers, for example.
Okay, any questions to the brace initialization?
Yeah, it's a hard word for you.
Initialization, yeah, always struggling. Yeah.
Good question. If I don't put anything inside this, what will happen? Do you have first code here?
Yeah,
we
yeah,
can
sure,
try it out.
sure.
I don't know. I think it will be a compiler error, because it's like writing age is equal to and then nothing.
Yep.
Yeah. It's now, I think it's a redefinition of the same, so you have to delete first age. Yeah.
Maybe we'll need it later.
But your compiler does not complain here. Maybe it works.
Yeah, let's see.
Yeah. Okay. Interesting. Yeah.
Yeah. Zero. Ah,
Okay. Great.
yeah. So also for the recording, the standard says it's initialized to 0. Yeah.
Okay.
Thank you for looking up. Perfect. Great.
Okay.
Any other questions to brace initialization? Can we have other variables inside of the braces?
What do you mean with other variables?
You mean something like
okay, okay. Yeah, let's try it out.
oops. So. Yeah, seems to work.
Yeah. So it's pretty much the same as an equal sign.
Great.
Okay, last topic before we go into the break. It's about const, and I love this this image here.
C++.
I know that nobody will say that C++ is just straightforward, but yeah,
Is it really that straightforward?
we can have constructs like this, and we will now resolve what this means.
There's a lot of const here.
It's actually a valid function or a valid method, a valid getter.
Yeah. But in general, const is a keyword in C++, which tells the compiler that I now make the promise that I will not change this, in this case here, this variable or any members or, yeah, anything we will see. And this definitely makes sense if we have some real constants. So for instance, if we want to use pi, we can define it as constant because it most likely won't change. But the age will change probably, so if we want to modify the value, we will get a compiler error.
So it's again not really a programming, it does not help you enhance your program, but it's just more like restricting yourself and giving you constraints how you can modify values or methods.
Avoiding any unwanted behavior and protecting.
And again, you can say to your teammate, you are not allowed to use this function in a specific way. I can define it, what you can modify and what not.
So, for instance, we can have constant pointers. There's a lot of const going on here. So we define the const int age. So this is a variable that cannot be modified anymore. And we have non-constant variable ID 20 here. And yeah, then the magic starts, I would say. We have const int pointer with the address of the age. Okay, that's perfectly fine. But if we now want to modify the value of the pointer, so if you want to modify the age, it doesn't work. It doesn't work because we have defined this pointer here to be constant. And as soon as it is on the left side of the asterisk, we say, okay, we cannot modify the value of the pointer anymore. But if we have the constant here on the left side of the asterisk, we can modify the pointer itself. So we can say, okay, dear pointer, now point to, for instance, the address of ID. So this is perfectly fine. And we have something similar for not modifying the pointer itself, but modifying the value. So again, two variables here. Now we say pointer should point to the address of ID. And if we then want to modify the value of the pointer, it's perfectly fine. We can just dereference the pointer and assign the value 2 to it. So as soon as the const is on the right side of the pointer of the asterisk here, we can modify the value however we want. But in this case, we cannot modify the pointer itself anymore. So it cannot point to anything else than age. It's confusing.
Yeah, and it can get even more confusing.
Yeah. If we have const on both sides of the asterisk. So again, we have two variables, and then we have the const int pointer, const, and the variable name, which points to the address of ID. And now we cannot do anything anymore. So we cannot modify the value by dereferencing the pointer because we have this const keyword here. And we can also not modify the pointer itself anymore because we have this const here. Yes?
Super easy way to remember this. Just read it from right to left. It's a constant pointer to an integer which is also constant.
Yeah, that's actually very good. So thank you for the tip. So reading it from right to left could maybe help you remembering this. Great.
Wouldn't one of the consts doesn't make that much sense to me, because if I already set the age variable, okay, you're pointing to ID, but if I would point to the age variable if I would use the end sign and age, then the age variable would already be const. Would I be able to change it with through the pointer?
If I understood you correctly, let's assume we have this example here. So we have the const int age, and we do not have a const int pointer, but just an int pointer, for example. This would not work. So the compiler would say, okay, you cannot point to a variable that is of type const int without having here the const. So you would have to explicitly write the const before the int, or actually somewhere before the asterisk, because otherwise the compiler wouldn't allow it.
Yeah.
Yeah. Yeah.
You cannot easily get rid of this const by just having a pointer that is not const to it. Yeah. So the compiler knows that and sees it, and then will give an error.
Okay.
So we now know a lot of them. So we know what this const is, we know what this const is, what this const is, but what is this last const there? What does this mean?
Let's solve the mystery. So if we define a function, or in this case, a method of as const, this means that this method is not going to modify the class in any way. This means that we cannot modify, in this case here, the age member variable. And this is also the reason why getters should always be const, because in a getter method, you don't want to change any member variables, anything that is related to the class. So this is a best practice, and we also encourage you to use const when you define a getter method. Does it make sense to you?
Because in all the libraries and all the stuff you're using, you will always see this const here after the method name, and it just means you cannot, or it's not modified inside. That's basically what it means. Yes?
If I call a function inside of the age that changes the class, is that an error or not?
If you call a function inside a const function, this function also has to be const. Otherwise, you get an error again. Yep. So again, the compiler is not stupid, recognizes this, and will give you an error.
So if you would write age is equal to 5 or whatever value, the compiler wouldn't allow it because the whole method is const. Does it make sense to you? Is this clear to everyone? Perfect.
Great. So this one was a method of a class that takes a pointer which value and pointer is not modifiable, returns a pointer which value and pointer is not modifiable, and does not modify the class itself. It's as easy as it is, yeah.
Kind of, yeah. Yeah. Are there any questions to const before we continue with the last quiz in the first part of the lecture? So, yeah. Of course, it's related to const. We have a method here, the setter method with the return data type const int, a parameter of data type const int pointer, and also the function or the method is const. But if we compile this, we will get an error. And which of these consts will produce or cause the error? All of them. Okay, let's wait 5 more seconds and then.
I already see the results and it looks quite promising. Yes.
Yeah. Why is this the case? Because we modify the class, so we modify the member variable age here in the first line of this method, and this is not allowed if we define the method here with the const keyword. So yeah, many of you got it right. Congrats. It's really great because it's not that easy to understand. And is there a question? Yeah.
So we are allowed to return type int into a variable of type constant.
Yes.
Yeah.
You are allowed to return a const int to, for example, the age. And that means that whatever function is calling this, they cannot modify this.
So it must also be const.
Yeah. All right. So
Great.
the conclusion of const, the compiler does not allow the modification, so you can restrict yourself and your teammates. And also, if you write a library, everybody who is using your code, for example, getter methods should be const always, because they should only return the member variable and the values of that. And objects, variables, and parameters should be const if they should not change. I think, yeah, let's make a break of 10 minutes until, let's say, 5:37. Yeah.